Let me broadcast the screen. You see the broadcasting? Okay. All right. Now, okay, this is the third week of the course, right? In the past 2 weeks, I know that most of the people do not have programming experience, right? But in the past 2 weeks, you have already like start to write program, right? You get familiar with the RStudio environment, this environment, and then you have already like do a lot of programming to in this environment. What we mean by programming, what do we mean by that? We mean we are computing the data object, right? And try to extract information in this data processing process. We try to extract information from data, right? That's what programming is for. And as I mentioned to you again and again, when we are learning programming, we want to like learn syntax, learn a lot of grammar, a lot of algorithm. That is not the right way to learn programming. I mean, for the business school student, I believe that the best way is to like, first of all, get familiar with the environment, and then I'll give you data, and then walk you through a lot of data cases, right? That's the way we are going to do, right? So this week we already start to do that, right? After learning some basic R, right? After learning the data type, data structure, some of the indexing technique, and some of the basic functions, right? I mean, we did not learn too much thing, right? We learn what is data object, what is data type, right? What is data type? I mean integer, I mean character, factor, right? That's the data type. And then we have different data structure, right? We have vector, we have data frame, we have like metric, right? And then every piece of data in the R environment is an object, right? A data frame is an object, a vector is an object, right? And you can put data object in the expression, right? And then the R environment will evaluate that expression, right? So you put data object in the expression, which is composed of object, operator, function call, right? Isn't it, right? So after the calculation, what is the outcome? When you evaluate the expression, the outcome is another object, right? After you compute the data, outcome is still the data, right? So you from time to time you have to name the outcome, right? So you can have further processing and step by step, right? In this sequence, the entire programming process is nothing but a process of defining or updating data object with expression, isn't it? Right? That's all, right? That's all we need to know before we start to write programming. And starting next week, we have already started to write program already, right? So you should still remember that so far in your environment, you should have a directory called 02R basics, right? And under this folder, there are a lot of notebooks, right? A lot of code and HTML, right? And so far we are in 2C, right? Unit 2C, right? So let's go to Unit 2C. So as you can see that if you open, if you click the Unit2C, the code will appear in this panel, right? In the upper left panel. And then if you click the HTML, it will actually, you will have two options, right? Open in editor or open in browser. Usually you do not open it in editor. If you open it in editor, you see the HTML file, right? Very, very complicated HTML file. It's nothing to do. You can do nothing with it, right? So you will not open this HTML in the, the editor. You want to open this HTML file. It's a web page, right? So you want to open it in your web browser, right? Okay, so that is Unit2C, okay? And last week we already start to, right, we have already read in the data, right? Okay, and we kind of like, with this str function, we actually examine the structure of this data frame, isn't it, right? A data frame is composed of a lot of columns, right? Okay, so each column is actually, we already mentioned this, right? In the data frame, every row is a subject of analysis, right? It's a unit of analysis, and this data is about comic characters, right? Comics character. So every row is a record of one comic book characters, but a character can have a lot of attributes. They can have some characteristics, right? So every column is basically an attribute of our interest, right? So with this data, we want to like examine the characteristic of comic characters, right? That's what we want to do today, okay? So we already see that we have like, let's we go to this place, right? Still remember it? Okay. We have like, if you actually use RStudio, then we already go to like here, right? So we have a D data frame, right? D is the name of the data frame, right? So under D there are 9 columns, right? 9 variables, and 7,250 characters, right? Okay, so this is the data structure, and then we want to use this data structure to do some data processing, right? And to extract information out of this data.
How did you get the values of D in your global environment?
Sorry?
How did you get the D data frame in your global environment?
We read it in, right? Okay. If I like, now in the beginning, when you open this thing, the environment is empty, right? Okay. So I already told you that the original data, the raw data, is kept in one of this file, right? In this data folder, there is a data file, raw data file, okay? And if you click the raw data file, you can actually see that it's actually in text, right? So we read the text file with this read CSV function, okay? You use the read CSV function, and then see when you come here, right? You need to do a thing. I told you already, right? You need to set this as working directory, right? You tell RStudio, here is your working directory, and the file you want to read is under data and comics 1, right?
Professor, but I opened this file from a folder. It does not show it in the files inside
Now you need to execute. This file is actually in your file system, right?
Right where your arrow is right now.
Yes.
Data, figure, unit 2A, operation function, all those files, they don't show on my.
Can you?
I opened this directly from a folder. It doesn't show here.
Oh, you need to do this. You need to look for the data from here,
Oh.
right? So can you look for?
Yeah.
Oh, okay, and no. Yeah, and put open.
Oh,
You see.
thank you so much, Professor.
Okay. And then you need to after you find this file, you need to set this as your working directory, okay? And then after you execute this command, this D data frame will appear in your working environment, okay? After you execute this code block, you'll see a D, right? So everyone should have a D data frame in your global environment. Okay. Then after we have D, we can actually check the structure inside D, and we can see how many row, how many column. We can see the column name. We can see the data type of each of this column, right? That's what we already know. Okay. Now, let's before we going further, let's check the data type of these columns, right? We already do some exercise last week, right? So how many numerics column do we have in this data frame? Two, right? These two, they are integer, okay? And this 7, they are characters, right? They are character string, right? But I already told you that some of this character string, they are actually factored, right? Okay. So how many of them are factors? 6 of them are factors, right? Actually, only the character name is a character string. The other character, they are actually factored, right? Because this is publisher, so they can only have 2 labels. Okay? In R, the categorical variable, categorical column, we call it factor. Okay? And for each factor, there are several labels, right? For example, for publisher, there are DC and Marble, right? For align, there's good, bad, and neutral, right? So there are a few labels within each factor, right? Well, if you look into the text file, you will see but every label is a character string by itself, right? Okay, but internally, the computer would compute factor in a different way with character, right? But in the R environment, actually, syntax-wise, I mean, when you are writing program, you don't need to worry about too much about the distinction between character and factor. Okay, you can treat them as the same thing. There are some exceptions, and we will talk about that later today. Okay. Okay, that's just so far we had, right? So after we know the data structure, we will start to examine the variable. Okay. Sometimes we will call it a column, right? For each of this attribute, we will call it a column. And sometimes we will call it variable. It's kind of like using it interchangeably, right? So if we want to examine the variable, the simplest function is called summary. Okay, in this notebook, every flower every flower is actually try to introduce you to a function. a useful function, right? Okay. So summary is the easiest way to examine column in the data frame. Okay. So when you use summary, you can see that for this numeric type of column, you will see its maximum, it's a minimum, right? Basically, there it will show the distribution uh, in the numeric type of variable. Okay. Yes.
Professor, is first and third quartiles, are those quartiles?
Yeah, that's quarter. That's quarter. Yeah, first quarter, third quarter, medium, right? And this is the average. Okay, minimum, maximum. So it basically gives you an idea because they are like 7,000 numbers, right? If I give you 7,000 numbers, you will not have an idea about what it is like, right? So this is what we call statistics, right? You kind of like summarize a lot of number with some summary, and that summary is called statistics. Okay, for example, like maximum, minimum, medium, an average, the standard deviation, that type of thing. They are statistics to help you understand a lot of number, right? So the summary of a lot of number. But for this character column, you can only see that because character have nothing to summary, isn't it? Right? So if you use summary, then it will only tell you they are like 7250 character string there, right? You see, you cannot see the detail within this the factor type of variables. Okay. So we have just like introduced a little bit um, some 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 uh, some of the statistics keywords, right? Some of the statistics terminologies, okay? Like distribution. Uh, this is the distribution, right? We want to understand how the variable vary, right? One way is to look into their statistics, look into their distribution, okay? Uh, actually, uh, besides using summary, we can also use some of the function like min, medium, maximum, or minimum, right? When you apply this function to a vector, right? Now this is a way to extract a column from the data frame, right? You use the dollar sign, right, to extract a column from the data frame. So if you apply this function to a vector, each column is a vector, right? So you actually get the statistics, right? Each individual statistics, like minimum, maximum, things like that. Okay. Yes.
I wonder why some vectors have the round brackets and some didn't have.
Sorry.
The main round bracket and the median and the max and the mean.
On
The
top of
first
that,
line.
Professor, above that, the first line, below, besides the flower.
The first flower,
The first flower. Yes.
we have the round brackets.
Yeah.
And the second doesn't have it.
Oh, they should all have that. That it's called parenthesis, right? Parenthesis. So in R we use parenthesis to do function call, right? Okay, because they are all functions, and if I want to explicitly express that it's a function, I will use that. I will write this way, right? They should all have the parentheses after them, right? Because they are all function call, right? Okay. And here, as you can see that this is a function call, right? So it should return this number, right? Okay. So in this case, I want to call for function call, right? And I want to put the result I concatenate all of the results and put it in a named vector, right? So the output of this code chunk is actually a named vector, right? It's actually a named vector. By named vector, I mean it's a vector. It's a numeric vector. Its value is a numeric vector, but every element of the vector has a name, right? And the name is given here, as you can see, right? Okay. Of course, you can also call summary with a vector, right? If you call summary with a vector, you actually it's easier, right? It'll give you minimum, maximum, and all of this useful information in one shot. Okay, so summary is like a more powerful function, right? Okay. And besides looking into the statistics, we can actually do the histogram. Okay. Does anyone know what? You should already familiar with what histogram is, right? Okay. Histogram is a way to visualize the distribution. Okay. We can see the distribution of this vector, this variable in this way. Okay. In their statistics. But a better way to understand this variable is try to see it, right? To visualize its distribution, right? In order to visualize the distribution of a numeric variable, you use histogram, okay? Now in R, let me explain one thing. This line, right? The par, and then there are some parameter under the par. It's just to set the format of the figures, right? So don't worry about that, okay? Just whenever you see in my notebook, if you see a par, then don't worry about that, okay? I'm just trying to like choose for example, I choose the font size, and I want to choose the margin of the right, of the figure, and I want to like put two figures together, right? That's this line is for formatting, okay? So if you cannot understand it, don't worry too much, okay? It's just for formatting. So the real code is starting from this one. So in order to plot the histogram is very easy. You simply call, you simply put the vector inside the histogram function called his, okay? And the second argument is just to give a title of the figure, right? So it's very easy, right? If you want to make a histogram, you can very, very simply do this. Histogram. And you put a vector inside the histogram. It has to be a vector, right? Because a variable has to be a vector, right? And if you want to use histogram, that vector has to be numeric, right? So only numeric has distribution. Let's see. So you can see that, right? This is the histogram of ear, right? As you can see that in the beginning there are some comics book, but and after World War II, the number of right comics like start to increase, right? And there's a setback in the around 1990, okay, and then start to grow again, right? And this thing is because I believe that this is 2010, and the 2010 is not completed yet. I mean when they collect the data, they did not collect the. If you take a look at the. You can see that the maximum is 2013, right? So What's the problem? It actually plotted here, right? Okay, so you can see it here, you can see it here, right? Basically, if you execute a code chunk, the output will appear below the code chunk, okay? And if you execute a comment here, the outcome will go to this place, okay? Now, so this is the, let's go back to a notebook, it's easier. So this is the distribution of ear, right? How about the distribution appearance? If you do a histogram on appearance, you'll see something like this. Okay? Appearance is actually the number of appearance for each of the character, right? For example, like let's see. See, in Batman appear like more than 3,000 times, and Superman like 25,000, right? 2,500, sorry. But some of the character they appear only once, right? Okay. So the reason that you see a distribution like this is because that within the data, sometimes only a few people has a very large number, right? It's a nature of the data, right? The real world, in the real world, we will see some distribution like this, right? And if you plot the distribution like this, it's very difficult to observe, right? Isn't it, right? You cannot see, you only know that most of the people is like, has a very low appearance. But you cannot tell, you cannot see the distribution as clear as this one, right? So in this situation, usually we apply a log. See that? In this situation, usually we will apply log, okay, before doing the histogram, okay? Hmm?
Professor, in the histogram, R itself decides the scale of X and Y axis, or can we decide the scale? Like it's 0,000, 2,000, 3,000. Can we change that to 0, 500,000? Like with
You mean you want to change the scale?
yes, because if the scale is wider,
Actually, you can change that, but in the basic, if we are using like histogram, this type of plotting tool, right? It's quite difficult to change it. Okay, it has a default and it's quite difficult to change it. Okay, later on, I will teach you another type of visualization tool, and in that tool, it's easier to do that. Okay. So, okay, so let's go back to when we see a distribution like this. Okay. What can we do with it, right? Okay. The best way is actually to apply a log, right? And in the business school, we usually use the 10 base log, right? The 10 base log, 0 is 1, right? And 1 is 10, right? 2 is 100, right? 3 is 1,000, isn't it, right? So you can see that most of the right, most of the character they have like from 1 to 10, isn't it? And this is from 10 to 100, and this is from 100 to 1,000, isn't it? Right? So you kind of like change the scale, right? So after you change the scale, after you apply log to this vector, you can actually like pipe it into a histogram, right? Okay, and again, the main argument is just to specify the title, right? See that? Okay, so so this is the way in R environment when you want to examine a numeric variable, first of all, you can see their statistics by summary, by minimum, mean, or you can plot its histogram, right? In this way, you will have a holistic understanding of that numeric variable, isn't it? Right? Yes.
So for this one with the log histogram that we did, how would you interpret it to explain it to somebody? How would you interpret it? Because I don't really understand.
Well, it actually the log is a mathematical transformation, right? Log is a logarithm or a square. It's kind of like a mathematical function that transform the numbers, right? Okay. And when this number is highly skewed in this situation, right? Because their distribution are very uneven, isn't it? So if you want to like observe this uneven distribution better, you can do a log transformation, right? So this log transformation has the function to to minimize to reduce the visual impact of the extreme value, right? The log function it tend to here this 4,000 is very far away, right? Okay, but if I apply log, it's like 3 point something, isn't it? So it has this transformation has a function to kind of like squeeze the scale, right? So that you can see the extreme value. So that the extreme value will not give you a strong visual impact like this one, right? So that you can see the distribution better, right?
I understand that, but my question is like, for example, if you want to look at the first bar in the histogram, would that say something like, or would you explain that as that's about 850 what characters that appeared more than 850 characters that appeared one time?
850. Where do you see?
In the log histogram.
Okay.
If you're looking at the bars and you want to explain, you want to talk about the numbers, is that interpreted as, this is 850 characters that appear with a frequency of one time?
No. Histogram actually, when you look at, let me use this one. It's easier, right? So as you can see that histogram, we are talking about a numeric variable, right? So now each bar in this histogram has a width, right? So in this example, this is 40, this is 60, right? So every bar is 5 years, isn't it? In this situation, every bar represents 5 years, right? So in this bar, it represents that from 1940 to 1945, you have about 100 characters. Okay? When you look into histogram, you need to, the first thing you need to specify, you need to, because this thing is a numeric, right? So it's continuous things, right? So if you want to count the continuous number, right? Especially when you apply the logarithm, right? So when you apply log, here this is 1, this is 0, and this is 1, right? So in this bar, this 580, right? They are actually between these two numbers. Let me- if you apply log to this vector, right, you actually will see a lot of numerics, isn't it? Because they are like 7250 number, right? So and when you do a histogram, now let's put it into a histogram. You see things like that, right? Okay. Now you're asking about what is this 850 mean, right? Okay. So you need to know the width of the bar, right? So as you can see that this is 0, this is 1, right? So this is 0.2, 0.4, isn't it, right? But because you already apply a 10 base log, right? So you need to like convert it back to the real number, isn't it, right? So you want to convert it back to a real number. How do you do that? You can do this, right? 10 so So here, we know that log 0 will compare to 1, right? Convert back to 1. And this is log 0.2, right? So it actually compared to 1585, okay? And the third one is actually like 0.4, right? So it's like 2512, isn't it? But actually, appearance cannot have like it has to be an integer, right? Yeah. So this is 1, okay? And for the second one is actually like 2, isn't it? Right? And the third bar is actually uh, this is 1. That these two numbers actually here and here, okay? And this two number is actually here and here. So this bar is actually 2, right? Yeah?
Professor, does that mean that the first bar is from 1 to 1.59? So does that mean that 1.5 common characters have appeared 850 times?
No, no. It means that we have 850 character appear only one time, right? This is the boundary, right?
But Professor, the y-axis is frequency.
Yes,
So they have appeared 850 times.
yes.
So two characters have
No,
appeared.
no, no. 850 character has appeared one time.
Then the y-axis says frequency, and I guess we're interpreting it as the 1, like frequently, not necessarily as a character.
But then shouldn't that, instead of frequency, shouldn't it be number of characters and the x-axis should be the frequency? Because they appear 2 times, that means their frequency is just 2.
Right, but I understand.
Because that is what the
Well, this in this situation, it just has that it has that confusion, right? But when you apply histogram, you should know that the in this case, it happens that this is another frequency, isn't it? Right? So it kind of get confused, right?
Sorry, Professor. So in a log histogram, the x-axis represents the frequency here.
In the log histogram,
Yes, the x-axis is always the frequency.
no, not really, not really. Yeah. It's well, actually, in this histogram, the x-axis is not frequency; it's the number of appearance, right?
Oh, got it.
And it could be anything, right?
Got it.
It could be the amount you buy, right? It could be the the uh, the height or the weight of a character. It could be the age of your customer, right? So the x-axis is, it depends on what you want to observe, right? And the y-axis is actually, because you are observing this numeric quantities, right? And we want to see that the distribution of this quantity. So you want to see the distribution of the quantity. So you need to divide, right? You need to divide the entire space, right, of that quantity into equal width, and then you count the number, right? Okay. And in this case, because you apply it with log, right? So you have to convert the boundary of the bar back to the real number, isn't it? Right? So the first bar is actually between 0 and 0.2, right? So it converts to 1 and 1.5. So this is just this 850 something is actually the number of characters who appear only once. Okay? And the second one is actually between 1.5 and 2.5, only 2, right? Only one integer is within this interval, right? So this is like about 600 characters appear only 2 times, right? And how about this one? How about the third bar? Let's send some a word. So what is this number? I mean, about 500, right? So what is this 500?
Characters.
Mm-hmm.
The number of characters who appear how many times?
3 times.
Between, yeah, 3.9.
Between 3.9 and 2.5.
Yes.
So it must be
3.
3 times, right? So about 500 characters appear only 3 times, right? Now how about this one? This one is pretty high, right?
About
About 100 and about 1200,
12.
yeah.
Appear
So it
6 times.
it represents characters that appear how many times?
6 times.
Is that right?
Between 3.9 to 6.2. So 5 times?
No. Let's look into the boundary, right?
6 times.
The boundary is, I mean, here is 3981, and here is 6.3, right? So this 1200 character, how many appearance do they have?
6. 4, 5, or 6.
Say it again, louder.
4, 5, or 6.
4, 5, or 6,
Okay.
right?
Okay.
You get the point?
Integers, yes.
Yeah, it's 4, 5, or 6, right? Okay. So, in this, so that's the point, right? That's the point. Okay. Any more question? Okay. Okay, so up to this point, we're trying to explain to you how to examine a numeric variable in our environment. Okay, that's kind of like a warm up. Okay, and this is 9:58. So let's take a 10 minutes break, and then when we get back, we will start to speed up. Okay, okay.